All right, ladies and gentlemen, we are about to get started on the first lesson of geometry. We did the algebra review. Now it's time to get going on some real geometry. All right, so what better title than getting started? All righty. So we're going to go over some naming convention for points, lines, planes, rays, all that good stuff, notation of things. There's going to be about 6 things that we're going to cover. So you can set up as a list or however you'd like to take your notes. But I'll help you out with that as we go. All right. So this would normally be done in class, but we're going to pick a point. So select your own point as you're watching this. All right. And all righty. Which point did you pick? Did I hear H? Ooh, I'm leaving that voice crack in. All right. I heard somebody say H was the point they picked. Now, if we're going to name a point, we just use a capital letter, H. Or if I think I heard somebody else say E, then you would label it as point E. You just have a capital letter. That's it. So if you want to jot some things down here, point naming convention or how to name a point, we just use a capital letter. All right? Not too bad so far, eh? Okie doke. Maybe put a couple examples there, you know. This stuff will become pretty much like second nature to you guys as we get going through this, okay? So to name a line, let's say we're talking about, if I were to say line AE, what part would that be? How would we notate that? Well, to name a line, it'd be AE, and we'd put a line with the 2 arrows over it. That would mean we're talking about this entire line right here, and it goes on forever and ever to infinity and beyond in both directions. Cool? There are multiple ways to name the same line. If, say, there was a point R right here, okay, right? Just capital letter next to the point. That's how you name it. I could call AR, line AR. That's the same line as AE because it runs along the exact same set of points, right? It goes forever and ever and ever in the same direction. Cool. RE would be another one. ER. You can reverse them when we're talking about lines. All right. Cool stuff. Okay. So a couple ways that we can do it. We can do it with any 2 points that are on the line like we just did. So let's say we're talking about this guy right here. This could be written as line AB, or you can use a lowercase cursive letter, right? You learn to write in cursive for some reason. Here we go. Let's put it to use. Right? Did they still tell you guys like in junior high or grade school, you're going to need to learn cursive when you get to high school? Okay. Anywho, just make sure we put that line symbol above, right? Which is that guy. And lines are one-dimensional here. If, fun fact, I guess. All right. Wonderful. You might be wondering, like, hey, what's this uppercase G here? That's actually talking about the plane that it's sitting in. So that whole flat, like, piece of paper kind of looking thing. Another day. We'll talk about that another day. All right. So what if we're talking about just that red portion of the line there? What would we call that? Well, that would be called a line segment. And we would notate that as AE without the arrows. Okay. Now, remember how I threw an R here before? I could not say AR and have it be the same as AE. That does not work in this case because it ends, right? It ends at R. So then we would only be talking about this section as opposed to the whole thing. So you can't name it a whole bunch of different ways. I could do AE or EA. Okay. So if we're talking about the naming convention for a line segment, only the 2 endpoints, right? And that's what I was getting at there. And then the line segment symbol over the top of it. Cool. How many dimensions? 1-dimensional. Yay, fun fact. I don't know if that's really that important, but hey, cool stuff. All right. I know we're cruising here, so you guys can feel free to pause at any time. I just like to try and keep these videos a little bit shorter so that they're not taking up so much time on YouTube and all that. And yeah, wonderful. Let me get a drink. Stay hydrated, okay? All right. Now we want to name only the red portion of the line once again, or red portion there. What's that called? Where it's like one side, it goes on forever and ever in one direction. My favorite band, but not the other direction. This is called array. An array for this one would be AE and we draw the arrow in the direction that it goes. We always draw the arrow going in that same direction, to the right. So you can't name this ray EA. Does not work that way. We also would not even say EA drawn that way. Like, I kind of get what you mean, but you'd never see a ray drawn backwards like that. All right. Now, to throw in the same scenario that we've been doing, if I put a point R here, could I say A, R, and have it be the same ray as AE? Well, and I'm going to use green here. If I were to start at A, go in the direction of R, and continue on forever, which is what a ray would do, one direction, going on forever, is it covering the same set of points? Yeah, it's the same thing. So these two would actually be one and the same then. Okay, just a different name for that ray. But you have to start at that endpoint where there's no arrow. Okay? And here's the good on that. So it has one endpoint and continues forever in one direction. Again, my favorite band. Not really. All right, the endpoint and any other point on the ray and the ray symbol. So that's the any other point on the ray, like we just did with the E or the R, right? And then our ray symbol is that guy, just the arrow going to the right. Awesome. Still one dimension because that's just exciting stuff. Lovely. All right. Again, if you need to pause, pause. Okay, time for some angles. All right. Now, if I say angle H here, I would just write it as angle H. That auto-corrected. That's not what I wanted. Hold up. Angle H. There we go. So I can name that as angle H. We know exactly what we're talking about. Or angle B. That's this guy right here. Cool? Not too bad. All right. Unless I start bringing some other things in, which I think I might. All right. But let's go over the angle definition first. Two rays with a common endpoint. Notice how these were indeed made up of this is a ray and this is a ray. Okay. That's pretty cool, isn't it? All right, so two rays with a common endpoint. I do remember this coming up on a quiz at some point. So, maybe pop that in the old noggin. All right? Cool. Now, when we're talking about this scenario, can you guys hear the dogs barking? Oh, man. Jenny's going to check out the situation. All right. If you haven't already, River Dog Jenny on Instagram. All right, give that a quick follow. Pause the video and pop on there real quick. She's becoming Insta famous. Alrighty, let's hop back to it. Had a brief interruption there. So now we want to choose an angle. Like if you said angle G, I wouldn't know what you're talking about. Are you talking about this one here? Are you talking about this one over here? Or this whole big one right here? Like, I don't know. All right, so we have to be very specific in these situations. All right, so if I want to name an angle when there's multiple angles with the same vertex, okay, that's a good word, vertex, I need to use three letters, okay? So I could say angle BGF, and I'd know we're talking about the one where I put one tick mark, okay? I put the arc and one tick mark there, right? If I said angle BGE, I know we're talking about that overall big one, BGE. And the last one we have there is angle FGE, and we know we're talking about this guy right here. Now, the other thing you can do with the smallest of the angles, and maybe I shouldn't say smallest, but of the smaller angles where there's no other angles between it, like angle BGF, we could mark a number 1 there and call it angle 1. Okay, so angle 1 would be a suitable name for that guy right there. Or I could put a number 2 here for FGE, and that could be another name for that angle. Well, we'd have to notate it on the diagram if it's not already done for us. We cannot number the big guy here, BGE, because it wouldn't be clear as to what angle we're talking about. We can only do it for this, like the small angles there, okay? Only those small ones. Lovely. Awesome. So let's formally write some of that stuff down because it's quite the exciting stuff. So using the vertex, which would be the single letter, angle B in this case in the diagram down here, using a number in the angle, that's angle 1 then, and then using 1 point from one side, then the vertex, and the point from the other side. This is basically your guaranteed. You haven't, shortchanged it or anything like that. But obviously it does take a little bit more writing. I think we'll end up using the number one quite frequently, you'll find. But if we're talking about larger angles, like in the last one where there's multiple angles within it, you got to use the 3 points. Okay? Let's keep it moving. Triangles. Yes. Love me some triangles. You'll be very fond of the triangles by the end of this year. All right. A figure with 3 segments as its sides. That makes sense, right? MN, NO, and OM. Okay? So the way we name these are the triangle symbol and the 3 vertices. So M, N, O. You can start wherever and you can go in counterclockwise or clockwise direction. It doesn't matter. You can't really screw that one up with triangles. When we get to quadrilaterals, there's a little more to it, but we'll get there when we get there. So name the sides of the triangle below. Actually, I already kind of said that. We'd have MN. We'd have NO, and we'd have MO. Those are my 3 sides. All segments. I put the segment marking on top. Lovely. All right. So it says name angle 1 another way. Well, another way to name angle 1 would be with my 3 points that are on it, right? So I'd have my point on one side of the angle, my vertex, which is N, and then the point on the other side. There we go. There's RNP. Awesome. Name 2 lines. So we could have line, let's say, RS, right? That is this guy right here. And I could say maybe, how about MN, which could have been named as, MP. That would be the other line right here. And it says name a ray with an endpoint R that goes in the direction of N 2 different ways. Okay, we talked about this a little bit. So we're talking about this ray here, R something. So I could use RN, as that's a point that's on the ray. There we go, put our ray symbol on there. Or I could say RS. Beautiful. Fantastic. All right. Then it says, can you name the ray from the question above, SR? Well, SR would look like this, going to infinity and beyond in that direction. Is that the same set of points? No. They share some points. We'll learn about what that means, what that overlap could be called or referred to as. But in this case, no. All right? They're not the same thing, not the same set of points. All righty. Let's keep it going. Oh boy, we got some little issues here with how this is formatted. Give me a sec. All right, did the best we could here. Without spending too much time. So I just put the what the marks should have been that clearly didn't show up in this. Sometimes these programs get a little bit freaked out by math type stuff. So anywho, line NS and line RS share the same set of points. Well, if I drew NS, that's this whole line right here, goes in both directions. And then if I did RS, do they share the same set of points? Yes, they certainly do. So that's true. All right. Another name for angle 1 is angle N. This is not descriptive enough, right? I don't know what angle N is. It's got a lot of angles with that vertex. So that's a false. Ray MN and Ray NP share the same set of points. Well, let's see here. Let me get rid of some of this stuff. Okay. Well, Ray MN is that, and then Ray NP is that. They're not sharing this spot right back here, so that one's going to be a false. It's a false for me. All right, and lastly, the vertex of angle 2 is N. So angle 2 is, maybe I'll get rid of some of the stuff so it's less distracting. All right, angle 2 is this one here. I know that because the number was written in there, and its vertex certainly is N. That is true. Awesome. All righty, let's keep it going. Union and intersection. All right, you may have seen this before. Union. By the way, this toolbox thing here, some of the teachers like to have a little toolbox note sheet. I just like to, if you see the word toolbox in there, that's something that we're probably going to use frequently. So what I would do is I would star it, highlight it, however you'd like to, really showcase something in your notes. Make a big deal out of it when you see toolbox. All right. So union means what do they make together? So we'll say together, and it's going to be notated with a U without the stick. All right. Intersection, that's going to be the overlap and will be notated with, we could call an N. Okay. So union, what they make together. Intersection is the overlap. All right. And of course, we've got some funkiness going on. Give me a quick sec here. All righty. So first one, angle EAC intersecting with segment AC. So angle EAC. So EAC is going to be this. All right. And intersecting with AC. So when I'm doing an intersection, I like to use two different colors, so that I can see what overlaps. Well, I can see the overlap is just segment AC. It's what they share with or what they have in common. Okay. Moving on, we got a union. Okay. So with the union, I'm going to use one color, and I'm going to see what they make together. So we have EC, ray EC. So it starts here and goes in the direction of C. And we have ray EA, goes in that direction. Ooh, so these two rays have a common endpoint. What does that create? That creates an angle, which we could call angle AEC, or you could reverse that to be CEA. Your call. All right, but that's our union. It's what they make together. Moving on. BE intersecting with FD, segment BE and segment FD. So BE is that one, and FD is this over here. Do they overlap? Nope. So that's going to be nothing. All right, the null set, the 0 with the line through it. Cool. That's how we formally write it in a math class. All right, triangle CAD. So CAD, let's find that. That's that guy. This fancy program auto snaps sometimes when I don't want it to. And then it's an intersection, so I'm going to use two colors. That'll be ACE. So ACE. Well, what overlaps here? Segment AC. Very good, children. Very good. I heard all of you. All right. Now it says if one point is chosen at random, what is the probability that the point is on segment AC? Well, how many points do we have? So when we're talking about this probability, we're not talking about it could be anywhere on here because there are an infinite number of points, so we can't really do probability with that. We're saying the named points, okay? So it's implied here that it's the named points. Well, we have 1, 2, 3, 4, 5, 6. We have 6 of them. And what's the probability that it's on AC? Well, there's 2 points on AC, so it'd be 2 out of 6, and we'll go ahead and reduce that to 1/3. All right, or 33.3 repeating percent. Cool. Here's one for you. What if I had said, just a what if here, triangle ACD? What's the probability that it lands on triangle ACD? And the reason why I bring this one up is because people tend to forget something here. If I were to draw ACD, there's still the total of 6 points on this thing. But if I were to draw a triangle ACD, how many points are actually on that triangle? There's 1, 2, 3, 4. It'd be 4 out of 6 or 2/3. A lot of people would just say 3 out of 6 or 1/2. So they forget about that point F that is actually on that triangle. Okay? Lovely. All right. I think I'm going to cut off here because it's probably starting to run a little bit long. Wonderful. You guys have a great day. America, freedom, rock and roll, and Costco.